Good morning. Welcome back to chemistry class. In our last class, we learnt about the types of solutions, about the types of mixtures, homogeneous mixtures and heterogeneous mixtures. We learnt about the true solutions which come under homogeneous mixtures. And today, we will learn about suspensions and colloids which come under the category of heterogeneous mixtures. So, these two also have some differences between them. We will be learning them today. Before that, let's see a small activity. Let's do a small activity by mixing salt in water in one glass. Okay, you can see that the salt completely dissolves in the water. Initially, you may see a little bit of salt in the bottom, but once you stir it well, you won't see any trace of salt. The particles of the salt, they distribute uniformly throughout the mixture. They dissolve completely. Yes, so it's a kind of true solution because you can't see any particles of salt. Now, in the second glass, mix some sand in it. You can very clearly see the particles of sand as the particle size is very large. So no matter how much you add and how much you stir, you can still see the particles of sand. And they form a distinct layer because they are heavier, they settle down in the bottom, right? So they can be easily filtered off also. Can you see a different layer of sand settle down in the bottom? Yes, so that's why it's called as a heterogeneous mixture. Now, this is an example for heterogeneous mixture. You can see that layer of sand there, right? Now try mixing some drops of milk in water. Can you see? The color of the solution changes. The milk completely distributes itself or gets dispersed throughout the water. And you can see the color change. It became translucent, right? The particles of the milk cannot be seen or differentiated, but you can see the color change just. So let's learn more about it in detail now. The first glass contains a homogeneous mixture because the salt components, the solute particles, the salt particles dissolved completely throughout the solution, leaving behind no trace. So that is an example for a true solution. But the other two glasses, they contain heterogeneous mixture. You will be surprised to know that milk is also a heterogeneous mixture. Though we cannot see the particles of milk separately, but that comes under heterogeneous mixture. We all know that sand and water is a heterogeneous mixture because we are able to see the particles of sand in the water. So let us know what are the differences between suspensions and colloids. Speaking of the particle size is the main determining factor between suspensions and colloids. So here if you talk about the particle size in suspension is greater, as I said. So in terms of nanometers, I can say that the particle size is greater than 100 nanometers. Now, how much is 1 nanometer, children? We all know that it is the 1 billionth of a meter. That means 1 nanometer is equal to 10 to the power of minus 9 meters, or in centimeters, I can say that it is 10 to the power of minus 7 centimeters. Now, 100 nanometers means in centimeters, I can say that it is greater than 10 to the power of minus 5 centimeters. When coming to colloids, it can be somewhere between 1 to 100 nanometers. Or I can say from 10 to the power of 7 to 10 to the power of 5 centimeters. So, it is variable. But it can be close to the homogeneous mixtures too, right? In case of a true solution, the particle size is much less than 10 to the power of minus 7 centimeters, or it is much less than 1 nanometer. That's the difference between the true solution, suspension and colloids. Coming to the settling, as the particle size is greater, what